All right, let's talk a little bit about lists, matrix, and vectors. We've learned about lists, and lists are basically one-dimensional arrays. If you think about any other programming languages, it would be array. You would not use a list. Though a list is not an array, it acts like an array. When we're using Numpy, an array is an array, but we're using Numpy in Python, so lists and arrays oftentimes get interchanged. So you will be moving data from arrays in NumPy into lists in Python and vice versa. So if we think about a matrix is a two-dimensional array. And in NumPy, the lists and vectors and arrays start at 0 and go up. So we have this is a vector, this is a vector, this can be a vector, this can be a vector. We can cut and slice and dice this matrix, this two-dimensional array, in any order. If we want to talk about numbering, we do row and then column. So this is 1, 2. If we're talking about the value there, that one would be 2, 4. In NumPy, arrays can be multidimensional. They don't just have to be matrices. They can be 3, 4, 5, 10-dimensional arrays. In other programming languages, you can make more than two-dimensional arrays. Oftentimes, by default, they're constrained to two dimensionals, but you can actually write a short function to make multidimensional arrays. In NumPy, it's designed from the ground up to make multidimensional arrays. Some of you may have been taught to never use more than two-dimensional arrays, but if you're going to be doing data analysis, you'll be oftentimes using multidimensional arrays that more than 2 dimensions. What we're going to learn to do is take our two-dimensional array or our matrix and slice it and dice it. And the confusion comes up when we're talking about arrays, matrix, vectors, and lists. There are no such things as arrays in Python, but NumPy adds the term array to the mix, and when you're importing NumPy into Python, your Python now has arrays in it. And arrays are different than lists, but a vector is a one-dimensional array from your NumPy array. So vectors are a NumPy construct that looks like a list or a one-dimensional array. And a matrix is just a two-dimensional array in NumPy. Some people will call any of the arrays in NumPy matrices, but in reality, it's only a two-dimensional array that is called a matrix. So NumPy, if you're talking about arrays, it can be a two-dimensional array, three-dimensional array, four-dimensional array, whatever dimension you want. If you have a list, a one-dimensional array, you can use a one-dimensional array in NumPy, but you don't call it a one-dimensional array, you call it a vector. And you can also use the data type in Python that's a list. It's a bit confusing. I'm not going to be a stickler about terminology, but you should try and figure out and use the correct terminology if you're going to be reading and looking at other people's code. So a list is a construct, a data type in Python that is similar to a one-dimensional array. A vector is an official one-dimensional array that we use in NumPy. An array is a multi-dimensional array in NumPy, and a matrix is a special format similar to like a square where it's a two-dimensional array in NumPy. We use everything, both NumPy, since we import NumPy into Python, we use everything in Python, but we need to keep the terminology a bit separate. And again, when we talk about the indexing values, we do row and then column. And as always, it's really easy. There's a single command to flip the rows and columns. So at one point in the program, you might be looking at rows and columns in one way. You execute a command, and suddenly the columns are rows and the rows are columns, and then you switch them back for some other command. So you need to keep track of exactly how you have your data ordered when you are thinking about indexing a particular value. We're going to learn about slicing, and that is selecting an entire column or an entire row, but we can also select from the middle over, or we can select a box over, or we can select from the beginning over, or we can select anywhere in between. So we can select a smaller value of an entire row, and that still becomes a vector. Now, the mathematicians might twitch at that, but that's still a vector from the entire matrix. And that's what we're going to be working on this week and pretty much for the next 3 or 4 weeks. Hope that all makes sense to you. If not, ask me in the discussion format.